Well, here we are in the wonderful, wonderful city of Valencia at the conference Euromembrane 2018. I say the city of Valencia is wonderful. I think you'd agree with that.
Yeah, it's absolutely fantastic.
The fact is, this room is rather boring and grey, but hey, you can't have everything. I'm joined today at the latest membrane bio by none other than the very erudite Professor TorOve Leiknes.
Thanks, Simon.
Thank you for being here. Always a pleasure, TorOve. I mean, what is it now? When did we first bump into each other? It must have been...
It's around 2000 or
2000,
99,
something to between. Yeah, that's a long time. A long time, anyway. So, anyway, great to see you again. Great to bump into at these conferences. I mean, what are you up to at the moment?
Long story. It's it's been quite a few years since we started off on this MBR.
The MBR journey.
Sort of journey.
Indeed.
So just to go back to the beginning, I remember some of the first meetings in Cranfield, the one that was 96, 98.
Good grief. Yeah,
that's a long time ago. And I remember the first meetings, we were like 60, 80 people.
Yeah,
sitting around the table. Talking about this MBR stuff.
This MBR thinking, what is an MBR?
And what is it, and how do we do it, and and then now suddenly we're in 2018, and MBR is kind of like a household...
It's a bit of a hand crank now, isn't it? How people get away with researching it is beyond me. It's just one big con.
Yeah.
But clearly you're still working in MBRs, or at least you were 2 years ago.
I call it MBRs still because, people understand what an MBR is, even though most people immediately think of sort of the commercial systems with the activated sludge, MBR, and so on. Which is cool. It's really nice to have seen the commercialization up through the years, and that we've actually been part of that history in kicking off the commercialization. That's, I think, pretty cool when you think about it, in the early 2000s. And
is that the royal we? I don't remember being consulted on that particular issue, but I'll take that anyway.
With the EU projects and everything, think of all that we did and the amount of effort and work we did.
There's a lot of stuff. There's no doubt that the EU did invest quite heavily in R&D into MBRs around about the turn of the millennium onwards. There's no doubt about that.
So sure. Look at the results of what's come out, the number of people, the commercial plants and everything. So I'm still working on MBR, but maybe not in the classical sense that people think about it. I'm still I work with more what I like to call MBR concepts.
Okay.
So it's using biological processes where membranes become an integral part of the whole process, more than the classical sort of commercial MBR plants.
Okay, so give me an example.
Okay, so I'll give you an example of that. Some of it is like right now we're looking at what I call a microalgae MBR. So we're looking at microalgae instead of bacteria, or in symbiotic relationships with bacteria to target wastewater treatment from a different perspective than the classical one, right?
Sure.
But then membranes become an important tool into facilitating the microalgae and the bacteria to do their job.
Right.
So it's not really what people think MBR, but it is a biological process with membranes.
It's just you've got photosynthesis instead of like normal...
Exactly.
Sort of heterotrophic system, I guess. On that particular issue, obviously algae is an enormous area of research.
Yep.
What do you see as the advantage of introducing an algae into like an irregular high rate algae pond or a photobiotic?
Well, so there's two reasons, or there's a couple of reasons for this. One is like, if we think wastewater reuse, and what I've seen happen over the years is a whole paradigm shift in what actually is meant by wastewater reuse. So recovering the water in itself is an important aspect of it, but that in some ways is just a byproduct of the wastewater reclamation for reuse, because there's a lot of valuable products in the wastewater that up till now haven't really been sort of taken care of and looked at. And so what we're trying to do with this microalgae MBR is to say, like, all right, instead of doing the expensive nitrification to remove ammonia, let's let the algae take the ammonia directly.
So you're treating the raw sewage with a PBR.
Right. Oh. And then on top of that, the microalgae, because of it's a photosynthetic system, are producing oxygen. So they oxygenate the water. They supersaturate the water with oxygen. So then we can use an aerobic bacterial reactor to remove the BOD or the COD without having to do mechanical aeration. And then on top of that, the microalgae needs CO2, right?
Of course.
So the aerobic part supplies some CO2, but not enough. But now you also have the option of, where you have operations of wastewater and power and whatnot to take the CO2 to feed the microalgae, which is treating the wastewater, giving you the treated water. But then when you harvest the microalgae, they're now a valuable fertilizer. So you can start using it for agriculture.
Oh, I thought you'd use it for biofuels.
No, biofuels was a hot topic for a while, but people have kind of realized that biofuels are not really the sustainable way to go.
Oh, okay.
So what I've seen is in that, microalgae type reactors, that the biofuel component has kind of slipped down. And if you're going to go into the high products that microalgae do, like the pharmaceuticals and cosmetics and so on, you need clean environments, which we don't have from the wastewater side.
Right, okay.
But with the wastewater microalgae, they have a high fertilizer value. They have a high COD value that can go into a fermentation for biogas production.
Right.
And those kinds of alternative uses.
Oh, that's amazing.
Yeah.
I would not have thought of just taking raw sewage, feeding it into a PBR, and then going from there onto an aerobic process, which I think is what you're suggesting.
So we've been playing around with looking at, it's not like...
You heard it here first.
Yeah. So it's not like a pre-post denitrification. I mean, it's not really denitrification, right? But it's kind of like, do you get rid of the ammonia first and then you polish the BOD with the bacteria, or do you allow the bacteria to get rid of the BOD and then the microalgae to do the ammonia, with the recycle? So it's thinking biological processes in a different picture,
right? With
membranes enabling that to get the treated water and the other products out of the wastewater through the biological process.
In that, just to sort of round this off nicely, because we are supposed to be talking about membrane technology, but hey,
this is membrane technology.
Where do you put the membrane in that process, TorOve?
In this system here is because we don't want the contamination between the algae and the bacteria. So there's actually two membrane systems. Right. One to keep the bacteria separated.
Sure.
And one to harvest the algae.
So you are using membranes for algae harvesting, just to concentrate the algae.
Absolutely.
If you concentrate the algae up it's just for the harvesting stage,
right?
Because you can't concentrate the algae too much in the bioreactor.
Then you have to exactly. You have to harvest. So you harvest the microalgae,
right?
And then you have to kind of do a post treatment on the harvested microalgae for the other products,
right?
But which brings to another interesting aspect. This combines in light, right? How do you do light? How do you get the different fixtures into the system? Do you do it only like the classical external? Or do you now have these devices where you can actually use fiber optics and send the light down?
Right.
And so now you get biomass growing, so it becomes an attached microalgae reactor instead of a suspended
attached
microalgae.
To the fiber optics themselves.
It attached to light sources. So they're getting the light source through the system. So it's opening up a whole new area.
It's absolutely fascinating. I mean, I wouldn't like to have to pay for that particular system, but certainly it's very highly renewable because you are using solar energy for the power source. And of course you're using algae, which, as you quite rightly say, means you can basically absorb CO2, pump out oxygen. Everything's moving in the right direction.
Right. But the interesting thing is that these integrated sort of concepts are not possible without the membranes.
Oh, right, okay.
Right? Because you need to have the membranes to have that degree of separation, that degree of filtration and harvesting capacity. So that's what makes it fascinating.
Oh, okay. Well, I must admit we've delved very deeply into the circular economy very early on in the conversation, but I have to say it sounds very fascinating.
Yeah.
You're quite unusual in that you also work in the Gulf.
Yep.
So we have that particular shared experience as well as the MBR thing. What do you consider to be sort of the most interesting aspects of working in that particular region?
Well, one of the things I find challenging about the Gulf is that, water is an issue, period. No matter which way you turn it and flip the box. Water scarcity is an issue. Dealing with water in some form or another is an absolute necessity for the societies there to survive. They are one of the biggest desalination areas in the world in terms
Famously
of volume
so, yes.
and so on. And my sort of contribution there, I think, is I asked the question: when you've desalinated all this water, just to chuck it out doesn't make sense. You need to reclaim it, reuse it somehow. And then you need to look at more sophisticated technology for a smarter reuse of that water.
Which is pretty much what the Singaporeans have been doing for about a decade now, I guess.
Except that when you look at a place like in the Middle East where we are, the food security is a big issue. You need to produce food. Mm-hmm. And so the only logical reuse for the wastewater, in my opinion, is for agriculture.
Yeah, sure.
And that's so that kind of puts a framework of the research questions or the research issues that I'm trying to focus on, where I call these MBR concepts or these integrated MBR ideas become then a tool to achieve that goal.
But this particular application of irrigation, as we both know, having both worked in that area, it's a stakeholder engagement, public acceptance issue, isn't it?
Absolutely.
Yeah.
So in parallel with the technology, there's an absolute need for the public education, public awareness, which has been done. I mean, Singapore has done it.
Yeah, absolutely.
Namibia has done it. Other places have done it. It's just a matter that it needs to be a piece of the whole program to implement it.
Okay. Yeah. You've sort of touched upon future opportunities already by talking quite extensively about the whole algae photobioreactor stuff. Is there anything else you sort of think might dictate how the technology develops in the future? And I'm talking specifically about membrane technologies, possibly MBR specifically, just according to current developments and projected future developments. What sort of things would have to happen to assist implementation?
Right. What I think is where I see the paradigm shift going in more sort of the wastewater reuse reclamation type thing is that people are getting their heads out of just the wastewater being recaptured. And this whole water, energy, food nexus, which we've been talking about for years and years, has kind of come more and more onto the surface. And up till now, it's been very much water and energy nexus, which has been very important. But the food element has been forgotten or not emphasized enough. So when you think about that on a global perspective, on average, 70% of our fresh water that we use is used for agriculture. And in regions like we are in the Middle East, it's up to 80-90% of the fresh water is used for irrigation. So food and water start to become a completely different sort of challenge. And that shifts, and when you talk about wastewater reclamation for agriculture, there's a huge demand for water in agriculture, and wastewater is going to be there all the time with population growth, urbanization, and so on.
Yeah.
So I think, some of the future MBR type ideas and membrane-based research on advanced water treatment is going to twist towards that application.
Sure.
Taking the water that's available as an impaired source and making it, applicable to agriculture.
Sure. Yeah, and I think that's a very, very good, very sound example of future application. So my last question on the technical side, is there anything you think has to happen to MBRs generally to make them more generally applicable or implementable more widely than they are already? Obviously, you get this impression of the sort of exponential growth of implementation of MBRs. I'm never quite sure how true that is. But in your view, is there anything that's holding them back more than the obvious things that, like membrane fouling, which isn't actually true, by the way, but it's the old chestnut which academics generally trot out. But is there anything else that you think, well, really this has to happen in order for the technology to be more widely implemented than it is?
So, touching on to the membrane fouling is an absolute, and I think it's accepted today. When you say membranes, you're also saying fouling. So, people have finally understood that membranes and fouling is something that's going to be there. We understand a lot of it. There are ways of getting around it. It's there. That's not going to be the big issue. But even understanding and ways to to kind of control fouling is going to be developed little by little to improve. I think the big step is going to be on understanding that when you combine membranes with biological and physical chemical processes, like in a bigger picture, you can take water of impaired quality and make it to different standards for whatever use you need, whether it's an urban use, cooling tower water, agriculture, urban agriculture. But then where people need to kind of understand that membranes are just a component in the big picture, in being able to accomplish what you actually need. So, when you look at the actual membrane component, it's not a huge percentage of a full plant.
That is very true, yes. About
so
15% or something like that.
So I like to say, look, we have a working horse already. It can be improved, it can be extended, but figuring out how to use that in different contexts and in different ways, probably with a more multidisciplinary type approach, is where the future is going to go in sort of this technology.
Well, we could probably chat for hours.
Oh yeah,
but I think we'll probably leave it there. Thanks very much for your time.
Yeah, sure, absolutely, pleasure.
Thanks.
Yeah.
Cheers.